Hello, I am Fatima, a student of Energy Systems Engineering at Kocaeli University, and currently I'm doing my student internship at Power Electronics Company. Today I would like to give you a more detailed introduction to our company, our products, and one of the most popular products, which are electric vehicle chargers. I planned for the presentation to last around 30 minutes. In the first part, I will provide more information about the company, and in the second part, I will focus on the chargers. And if you have any doubt, feel free to ask your questions on the email that I have left in the end of the presentation, but also you can leave your questions down below the video. Power Electronic is a company founded in 1999, located in Umrani, Istanbul. We are engaged in the manufacturing, assembly, sales, and project design of special products in the field of power electronics. We have become one of the leading companies in Turkey, and we are also recognized among power electronics brands worldwide, especially in Europe. Our vision is to be future-oriented and leading company in our sector, and our mission is to produce in a safe, economical, high quality, and eco-friendly manner. Our primary goals are to promote the company worldwide, maintain customer satisfaction and quality, and keep upgrading our production in line with the technology development. The address of our factory is İpekçi Street number 12 in the Umraniye district of Istanbul. Our research and development team, as well as the sales and design team, are located here. Another center is under construction in a neighboring Gebze district of Kocaeli city. Our power group is made of 6 teams. Power engineering team. Power engineering team provides consulting, design, and project planning services related to power electronics. Meanwhile, our main branch, Power Electronic, is involved in the sales and manufacturing of power electronics products, such as UPSs, rectifiers, inverters, AC/DC chargers for electric vehicles, etc. Power Solar team is engaged in solar system design, solar material sales, and preparation of land for solar projects. We also have our teams outside of Turkey, in the Netherlands and Germany, and soon in England as well. To our achievements, we have 24 years of experience, more than 10,000 satisfied clients, exports to over 50 countries, 55 service centers in Turkey, and 40 international service centers. We have completed over 500 private projects with a team of 45 people, and also our products own quality certificates. I would like to mention that our research team has been supported by the Turkish National Agency TÜBİTAK, which manages research and development institutes according to national priorities. TÜBİTAK also serves as an advisory agency for the Turkish government and acts as the Secretariat of the Supreme Council for Science and Technology, the highest body for science and technology policy in Turkey. In addition, we possess quality certificates and products with TSE and EN certificates. We also provide 24/7 service support offering technical assistance and frequently satisfaction surveys for our customers. Here you can see a list of our products. On the left side, we have electric vehicle chargers of various models and power capacities, which we will discuss in detail today. In the middle, you can see rectifiers, battery chargers, voltage regulators, etc. You can explore the complete list of our products on our official website, powerelectronic.com.tr. You can find the link in the video description. These are some of the major companies we have collaborated with who can guarantee for the quality of our products. Now let's move on the main topic of our electric vehicle chargers. We offer 5 types of chargers which differ in their outputs, powers, and applications. Actually, before we start, I would like to explain the types of electric vehicles: battery electric, hybrid, and plug-in hybrid vehicles. Hybrid vehicles cannot be electrically charged in any way. The batteries in these cars are charged through internal combustion engines, mainly when the car is idling or has excess power. The engine acts as a generator and charges the batteries, which later power the electric motor. Hybrid vehicles often have regenerative braking system, converting kinetic energy into electrical energy during braking and deceleration, which is stored in the battery. And this allows the reusage of energy during acceleration, reducing fuel consumption. On the other hand, we have plug-in hybrid vehicles that can be charged through chargers too. And the third type are fully electric vehicles, which do not have internal combustion engines and are powered just by electric motors using energy from batteries and that are charged with the help of electric chargers. This is a simplified schematic view of an electric vehicle. We have 2 types of inputs, AC and DC. If the input current is AC, it is rectified through the rectifiers and filters, and then it charges the high voltage and low voltage batteries through the battery charger. The low voltage battery supplies power to the smaller loads, while the high voltage battery powers the vehicle by converting the current through the inverter to drive the electric motor. As for AC and DC inputs, the main difference lies in the charging time. DC chargers can charge a vehicle much faster, making them ideal for placement on roads like highways. However, if you have more than 2 hours for charging, you can use AC chargers, which are generally more used and more recommended, and they are also cheaper than DC chargers since they do not include the built-in rectifier. It is important to note that constant charging with a DC charger is not advisable as it can shorten the battery's lifespan. The higher power output of DC chargers can lead to overloading and heating, which can decrease the battery's lifespan. Slower charging is controlled charging, so it is always better for the battery. AC chargers are produced with a power range from 3.7 to 22 kilowatts, which is global standard, not just in Turkey. On the other hand, DC chargers are, as mentioned earlier, have higher power output and they are produced in the range of 60 to 300 kilowatts, but also we produced chargers with 30 kilowatts for some private customers' requests. It's worth mentioning that you can upgrade the power of DC chargers without getting a whole new device, because the power drawn by the battery is determined by the rectifier, which is built in the DC charger. So adding more rectifier modules can increase the output power of your DC charger. The first one on the left is home time AC charger, also known as an offline type device, as it does not have any external display. Its operation is straightforward. You just plug it in and start charging. The power of the charger ranges from 3.7 to 22 kilowatts, with 3.7 to 7 kilowatts being single-phase chargers, and from 11 to 22 being three-phase chargers. They're usually wall-mounted, but can be made with a stand if requested. They can come with a cable and the socket, or just with a socket, depending on your car's type, where some cars might have their own cables. Also, as a socket type, we serve sockets for European standards, but also for some private requests, we can sell sockets for American standards too, if asked. The second model is a business model with a screen where you can read the QR code, download an application, enter your data, credit card information, car model, and the amount of money you want to charge. If you want to stop charging before completion, or if the battery gets charged before your expected time, then the remaining money will be refunded. But as soon as the device reaches the prepaid amount, the charging will be stopped. Also, you can use a power card instead of loading a QR code. With the card, the app can work without Wi-Fi. The dual model works on the same principle as the business model, but has two outputs, allowing it to charge two cars at the same time with 22 kilowatts per each car. The fourth one is an AC/DC charger with an advertising screen that shows both advertisements and the charging status. It has two AC outputs with the 2 times 22 kilowatts and one DC output ranging from 60 to 300 kilowatts. Here is also a fast DC charger with 2 DC outputs in the power range from 60 to 300 kilowatts. Here we can see schematic representation of charging with AC chargers. The current is directly taken from the grid, and through the built-in rectifier inside the car, it is converted into usable current for charging. The charging power is determined by the capacity of the rectifier in your vehicle, so the charging speed does not actually depend that much on the charger's power. For example, if you have a 22 kilowatts AC charger and your car's rectifier can handle only 10 kilowatts, it will still charge your battery in the same time it would take with a 10 kilowatt charger. However, it is generally recommended to go for a charger with a higher power, because you might upgrade to a higher capacity electric vehicle in the future, so you won't have to buy a new charger again. Although the diagram shows two different places, both AC and DC electric vehicles can charge the car using the same input hole. The only difference is the shape of the plug. For AC charging, There are typically three-phase, neutral, and ground connection, while for DC charging there are only positive and negative connections. With DC chargers, the current is being rectified inside the charger. So the structure of these chargers is more complex. They require more space and they are more expensive than AC chargers, of course. Here, based on the battery capacities of some car models, we can see the charging times. For example, we own a Renault Zoe, and to charge it from 0 to 60% with a 22 kilowatt converter, it takes about 2 hours, while to reach to 100%, it takes around 2.5 hours. Renault Zoe 50 has the possibility of DC charging, and it takes 1 hour to charge with a maximum DC charging power of 50 kilowatts. Even if it charged, for example, with a higher power charger, for example, 175 kilowatts, the maximum charging power will remain 50 kilowatts still. On the other hand, there are other electric car models, as you can see, that can charge at higher powers. Here, based on fuel and electricity prices in Turkey and anywhere in the world, we can come to the same conclusion that having an electric vehicle and charging it privately is the most cost-effective option. Charging with electric energy is much more economical than using gasoline or diesel anyways. Here, I want to recommend a website called Electric Vehicle Database, where you can see the range, charger power, and battery capacity of various electric vehicles. When you want to choose a charger, you need to pay attention to several factors. You should consider where you will use the charger, whether it is for private use at home, in a shopping center, or in the highway. Also determine the required power and whether you need the AC or DC charging or both. Consider the installation method, whether it will be wall-mounted or not, and the number of charging ports. Also, it may be desirable to have communication with a RFID card. For example, you can place AC chargers in front of your company, in the parking lot of a residential building, while DC chargers are more recommended to be installed on highways and gas stations where the service needs to be fast. Let's return to the topic of our available models. Our home type chargers have a Type 2 connector used in Europe and in Turkey too. The single phase ones range from 3.7 to 7.4 kilowatts, and the three phase ones from 11 to 22 kilowatts. Our research team has also developed a control card for dynamic load balancing, which provides additional safety for all other appliances in your home. Installation and usage are very simple. It can be used with a cable or just with a cable plug if your car already has one. It is suitable for use in outdoor environments with a temperature range from -30 to +50 degrees Celsius. A business type EV charger has the same specification regarding power range with a Single phase ones ranging from 3.7 to 7.4 kilowatts, and three phase ones from 11 to 22 kilowatts. The only difference from the home type is that it can be connected to the network, meaning it can be connected by Wi-Fi and Bluetooth, allowing remote control. It has a 4.3-inch screen that displays the charging status, your car battery capacity, charging power, and the amount of electricity pulled by the car once the charging is finished. The dual model has two outputs, and all other specifications are same as the business and home models. The only difference is that it has a slightly larger screen of about 7 inches. The fourth model is one of our best models, I can say. The AC/DC model with an advertising screen. It has two AC outputs of 22 kilowatts and one DC output ranging from 60 to 300 kilowatts. It has a 55-inch screen and is mostly used on roads, in front of shopping centers, hospitals, or any place where advertisement visibility is needed. The commercial DC type is produced in two cabin types, a smaller one from 60 to 180 kilowatts, and the larger one with range from 160 to 300 kilowatts. It has two DC outputs, so it can charge the two cars at the same time. For example, if DC charger's rated power is 120 kilowatts, then it is important to mention that when two cars are being charged at the same time, each car can charge at 60 kilowatts if it's charger with a 120 kilowatt capacity. But when a single vehicle is connected, it charges at full 120 kilowatts. But of course, as previously mentioned, it is important to know that know the maximum DC charging power of your car. We also have a DC charger with a large screen. And here is the catalog with all our products, all the models of our chargers. And also I want to add that we produce models according to the specific requirements for our clients. When it comes to our software, with our software you can remotely monitor faults, start and stop charging, as well as view the locations of our chargers and their prices. To assess our application, you can download it from the App Store when you search for Power EV Charge, and you will find our application. When you get the application, the first thing it will ask you is to enter your details, such as a phone number and credit card number. After that, with just reading a QR code, you will be able to charge your car immediately. Are examples of some of our installations in Ankara and Istanbul, AC/DC charger installation, or just DC installations. Here, one of our colleagues shows how to establish a connection with the charger, and he simply loads the RFID card. And that's it. Here are some examples of our AC installations, like in Antalya, where we designed a solar on-grid system on the roof of a parking lot in front of residential buildings. Here we see some solutions to increase the efficiency of our systems. Projects that we also work on are solar parking lots. So solar panels are on the roof, our EV charger underneath, and storage on the side to store excess energy. Some of our completed projects. We also offer hybrid solar home storage systems for your homes, which can reduce your electricity bills in the coming years. These are the types of the projects where your home appliances primarily take energy from the panels, store excess in batteries, and when the panel's energy production is insufficient, it draws energy from the grid. Also, our company provides all the elements and installation in addition to the design, making it a turnkey project. This way, we have a vision for some future projects of electric charging stations combined with renewable energy sources. For the end, why you should choose our company. First, we have certification for our domestic production, and also we own CE certificates. Also, we are very flexible regarding production according to our customer requirements. We provide installation, technical support, and offer varieties and affordable prices. Also, we own an electric vehicle charging network operator license that we got this year in February. That's all I have to say. Thank you for your attention.